lead outs, what are they? So we've got a part you're going to cut out. Let's say it's a cylinder. So from the plan view, it just looks like a circle. And then in an elevation view, it would look more like this. Okay. So without a lead in or a lead out turned on, you start with your bit. Here's our bit. It's going to move right over to the very edge. It's going to cut tangentially to your part, right on the edge, right? So if you're looking plan view, here's your bit, right? And it's coming up right to the edge of your part. It's going to start to cut. And you know, you set it to whatever depth it's going to start cutting at. So if you either be full depth or partial depth, that's up to you to program. Anyway, now it's going to go and cut around your part. It's going to cut around, like cut out your shape.
Instead of erasing it, why don't we show on the opposite side?
What's that?
Instead of erasing it, why don't we show on the opposite side?
Okay, sure. Yeah. So instead, sometimes you don't want the bit to just plunge in right at the edge of your part. And there's reasons behind that, mostly to do with concentricity of the bit. The bit does turn fairly straight, but if you were to look at a very micro view of it, it would actually be slightly wobbly. This is called runout, and depending on the machine, the runout is, in the state of repair for the machine, the runout can be quite high. It can be a couple thousandths of an inch. And that makes a difference when you care about the edge of a piece of plywood, for example. So sometimes we need to have a lead in, which means that the tool is going to start outside instead of right on it. It's going to start outside of your part. It's going to come down to this depth here. So we'll start again with our bit again. And it's going to come down to your depth, and then it's going to move in, right? And it's going to move in to your shape. So it starts, goes in, moves into your shape, okay? And then it's going to start your cut. And a lead out is the opposite of a lead in. It's going to move out once it's done. Does that make sense? That's what a lead in and a lead out is.
And so
a ramp is this, if you're curious what a ramp is. Here's our, in plan view, here's our cylinder. A ramp would be, here's our bit. Let's say it's going to lead in. It leads in, and then it starts its cut, and it's going to ramp around like a helix all the way around your part, so that it's not, it's balancing the amount of stress at the bottom and at the side of your cutting bit.
interesting.
And you want to have a ramp usually. Sometimes we plunge depending on what we're trying to accomplish, but sometimes you have to plunge if the pocket you're cutting is too small
Okay.
to have a ramp in it.
And because all of these cut on the side of the tool, having a lead in leaves you with a much cleaner surface, despite any what'd you call it? Runout
yeah.
that might be there, because
Yeah.
now it's up against the side and
So-
it's actually cutting.
Yeah, so they're called witness marks in woodworking. So I don't have any good examples here, but if I'm running my bit and I don't have any lead-ins or lead-outs, I'm going to run all the way around this thing, and then I'm going to stop at the same place and just move up. As I'm moving up, there might be some concentricity problems, and you're going to get a little mark on the edge. But if you
Right.
move in and then you start your cut, it reduces the chance of that happening.
Right,
It
and
could
then
still
the
happen.
lead
but-
out also prevents
Yeah.
that on the
Is this one right here? No, that's
That could be a witness mark. They look kind of like that. They look more like this, but I don't know if that's what those are. They may or may not be witness marks. It could be something else. But